All right, so in this lesson, we're going to look at calculating the wall and footing amounts for concrete. So I know the volume of concrete for the wall, the volume of concrete for the footing. Typically, these are done in two separate pours, so we're going to look at them separately. So here's our picture of our foundation, just a refresh from last class. So we're going to need to know the length of the walls, because if we stretch those walls out in one long stretch, it would make a very long rectangle. So we're going to need to know the length of the walls. You know how to do that with centerline perimeter. We're going to need to know the height of the wall, which will given to us in our plan. And we're going to need to know the thickness of our wall. And we'll need to know the same information for our footing, which will be below. So here's our wall up above. So we can see, based on this picture, that our wall is just a rectangular prism, which will be length times width times height. Excuse me. And then our footing is another rectangle. Now, the purpose of having a wider footing is it spreads out the pressure from the wall pushing down, which gives us more support. That's one of the reasons for having a footing with a much larger base. It makes it more stable as opposed to all of the weight of the concrete pushing down on just this narrow section. Now, one thing to note, you're going to find there's going to be footing width and wall width. You're going to have two widths to contend with when you're doing your calculations, and that could cause some problems for calculating the centerline perimeter. When calculating centerline perimeter, you will only use the wall. Okay, you will never, ever, ever use your footing width to find the centerline perimeter. And we'll see why that is when we look at our blueprint. So I'm going to go through a couple of example questions, and the example questions you can use for practice. I'll go through two of them. What I would suggest is I'll go through two, and I'd suggest pausing the video, trying the next two on your own, and then just checking your answers. That will tell you rather than posting a separate practice sheet. There's only limited diagrams that I have available, and I had to save a few for a test too. So when you're calculating the volume of concrete, we're going to always use our wall thickness. Why will we use our wall thickness? I said we'd see it from our blueprint. Well, you'll see here that these measurements of the outside, they're inside that dashed line. So the dashed line's the footing. They're the actual measurements to the edges of the wall. That's the reason why we're always going to work with our wall thickness as T in our centerline perimeter formula. Okay, so that's one place where you can find it. Now, we'll just take a second before we start. We want to have all of our measurements at the end in cubic meters. So let's go through and just quickly put decimal places in so that we remember how many meters we have, so that we don't accidentally end up with millions of cubic millimeters. That's going to be a bit of a nuisance. Now, this little break in the diagram here just shows that it's not drawn to scale. It's kind of crunched down, and it's just to give you a visual. Okay, nothing too serious to worry about there. First thing, let's calculate the centerline perimeter. So think about back to the formula from last day. Centerline perimeter is the same as the perimeter for a rectangle. So our centerline perimeter is going to be length plus width. Let me put the 2 in front of it, because it's not going to, if I put it behind, it's not going to look quite the same, and I didn't need enough space. 2 times length plus width. 2 times the length plus the width minus, remember our center line is inside of that outside measurement, so we have to subtract 4 thicknesses of the wall. Okay, so putting that into our calculator, you're going to have 2 times 13.6 plus, make sure you do order of operations, 9.8. These have to get added first before you multiply 2, minus 4 times 0.2. You should have got 46 meters. Okay. Now, if we want to find the strip footing, we're going to be dealing with just this component. Here's our strip footing down here. So I want to know, well, how much concrete's needed for that? Well, if you think about what's the area it would take up, or you can think of what's the length of it, the footing is going to be the length of the centerline perimeter times the width of the footing. That'll give you basically the area, the footprint that it will take up, times how high it is. So we're going to end up with 46 times the width of it is 0.6 meters. And notice I'm using 46 meters, 0.6 meters, and 0.2. I'm not using millimeters anywhere. And we're going to get 5.52 meters cubed. Nice, easy calculation. How much concrete is needed for the pads? Well, this is just like a normal air volume question, just like you would have had before, except we switched everything to meters at the beginning. So you have 0.9 times 0.9 times 0.15, because they're just square pads. We know how length, width, thickness. And you will get 0.1215. There's 3 pads, so 3 times 0.1215 leaves us with, and we can round to 2 decimal places quite safely, 0.36. Now, if you're looking at it going, are you rounding? Should I always round up or should I always round down? When you're doing these calculations in the middle, unless a question specifically says round up, you can just follow the math rule. When we add waste at the end, which we're not going to do here, we'll wait until after we've done floors to add the 5% or 10% for waste. That would counteract any rounding variations, okay? So you don't have to worry too much. Now, after you've added waste, that's where I would do the forced round up or the forced, in this case, round up rather than a forced round down, okay? So that's one of those things that can help you in here is just follow the standard. And then once you get to the very end of your question, once you get to the final number, then decide whether you're doing a forced round up or a forced round down. You know, for this scenario, you would pour your strip footings and your concrete pads would likely be poured the same day, and then your walls would follow. So for wall concrete, it's the same formula as our strip footing concrete, we just have different measurements. So the length of the wall is the same, still down the center, 46 meters. The width of it is 0.2 meters times a height of 2.4 meters. So length times width times height gives us 22.08 meters cubed. So if I was doing a quote and I wanted to know what's the total amount of the concrete that I need to build them for, these would be the 3 numbers that I would add together in order to find out what's the cost of concrete going to be. All right, let's do another example. First question, is this a jog or not? What shape is it? Remember I said before, a jog will make like a J or a U. In this case, we have an L. An L cut out on a corner. It is not a jog. I say not a jog. It's not a jog in the definition of centerline perimeter, okay? Sometimes people will use the word jog for that, but it's not the jog. It doesn't have 2 sides on it. So I don't know if I make that more confusing or less confusing. I do know there's a couple questions and in there, and they talk about that shape as being a jog, but that's not the jog that we have for our centerline perimeter formula. Just let me go back here to our question. There we are. I have a notification that I have a virus on my computer that keeps showing up, and it's wanting me to do a restart at very inappropriate times. So every time I cancel it, sometimes my screen jumps. So the first thing, let's calculate our centerline perimeter. So centerline perimeter, since we established that it's not a jog, it's going to be 2 length plus width minus 4 thicknesses of the wall. So 2 length, oh, just a second, we need to do some calculations. What is the length of this wall? Well, we're going to have to add these 2 together. 7,350 plus 7,250 gives me 14,600 millimeters. Okay, then down the side, 7,600 plus 3,350. See if I can, gives me 10,950 millimeters. Okay, now let's do the same thing as we did before. Let's put some decimals in so we remember that we can't do like 700 times 700. We have to do 0.7. Now, if you get a really massive number in the millions for these questions, whoops, that will be your clue that, wait a second, did I use millimeters? Because you're always going to be using meters. Unless we do some feet questions where I have cubic yards. That might be a good monkey wrench to throw in for you for an extra. Not today. We'll leave that for later. So for our length, now we have 14,600 millimeters, or 14.6 meters, plus our width is going to be 10.95 meters, minus 4 times the wall thickness of 0.25. And when I put that in my calculator, I got 50.1 meters. Okay. Now to find the strip footing concrete, same thing as before. 50.1 times the width, 0.61, times the height, 0.22, leaves us with 5.76 cubic meters. We want to know the pads. Now, what I find for doing the pads, I find sometimes the easiest just to do it in here. So 0.7 times 0.7 times 0.18 leaves me with 0.0882. And then for this one, I've left my decimals in. 0.8 times 0.8 times 0.2 gives me 0.128. Now that's just because sometimes you run out of space and I only have so much screen space here. So for the pad concrete, I need to add all the pads together. So I have not 3, I only have 2. I have 2 pads that are 0.0882 meters cubed. Plus, I'm going to have to add in 4 that are 0.128 meters cubed. And if you multiply first and then add the 2 together, you will get a total volume of 1.07. So multiply first, then add them together, and then round at the end here. And for the wall concrete is going to be length times width times height. The length is our center line perimeter. So 0.51 times the width of 0.25 times the height of 3.2. And that leaves us with 16.3 cubic meters. So actually really straightforward calculations. If you want, I'll throw boxes around these. So if you're scanning for them quickly, you have all your answers. So I think at this point you should, other than maybe refreshing calculating center line perimeter, you have what you need in order to maybe do the next 2 questions. So I'd recommend, let's say pausing the video, printing off the 2 examples, or opening up the PowerPoint, just writing down the 2 examples and calculating them and see what you get, and then coming back to the presentation and checking your answer. I'm not going to give as much detail in the last 2 examples. I'll give you some detail for center line perimeter, and then I'll just give you the final answers for the strip footing, pad concrete, and wall concrete. So this question, we do have a jog. Okay, so our formula, 2 length plus width minus 4 thicknesses of the wall plus 2 jogs. Now, in terms of our wall length, adding these 3 measurements together will give you your overall length. And I have 15,100 or 15.1 meters. On this side, we're going to have 10.6 meters. And our jog is 3.8. All right. And putting that in, you should get 58.2. That's a 5 on a 6. Might as well erase it and make it show up the way it should. 58.2. For your strip footing, I'm going to give you just the answer. You can check it. I have 6.7 meters cubed. So that's using these measurements. Oh, just a second. We don't have. Let me hide the last question. Let's go backwards here. I'm looking at, wait a second, my numbers aren't matching. I jumped a question. So for your strip footing, 8.2 times 0.45 times 0.22 will leave us with 5.76 meters cubed. For the pads, total, I'll just give you the total. I'll let you check them. I have 1.07 meters cubed. So you're going to get a couple small numbers and have to add them together. And then for the wall, 58.2 times 1.4. So this is an example, this 1.4 meters. This would be example of just crawl space basement. So you're just down below the frost wall. Or it could be say something like a split entry where you're coming in, not a split entry so much as something that's only got a partial basement. So partially below ground and maybe the rest of it is above story. I guess split entries are often that way where you have your steps up and then you go half the basement's exposed. So that would be an example of maybe that shorter basement times 0.2, 16.3 cubic meters. All right, so if you're not getting those numbers and you're not sure why, shoot me a message, let me know. The only one I think you shouldn't have questions about is the pad concrete. And the biggest thing I could see there is if you happen to miss putting things in meters. And then for the very last one, this is one that I really hope you took the time to do just because it's got our short jog in it. So we have a short jog here. It's the two offset sides. So the only measurement we're going to need to worry about is the short jog. So here's our jog. So we're going to have 2 length plus width minus 4 thicknesses plus 2 jogs. Now our length, we need to add these four measurements, those 3 measurements together. And it would help if I actually had that question in front of me. Adding those 3 measurements together, you'll get 15.25 meters. Okay, so 2 times 15.25 plus 9.5 minus 4, make sure you use the wall thickness, times 0.25 plus 2 times, and it's going to be 3.25. Squeeze that in there, and you'll get a total central line perimeter of 55 meters. In terms of your strip footing, 55 times 0.61 times 0.22 is going to leave us with 7.38 meters cubed. Pad concrete, I'll just give you the final answer, 0.63 meters cubed for all. So I'll let you do the calculation on that. And then for wall concrete, 55 times 0.25 times 2.8 leaves us with 38.5 meters cubed. So that gives you your calculations for all of them. So if you've had a chance to practice those and things are making sense, give it a try. If you're getting stuck with central line perimeter, go back and try the central line perimeter again. You have 5 attempts on it. You're not penalized if you use all 5. I just give you some really good practice for remembering the formulas. That's maybe the trickiest part, is remembering that central line perimeter. If you have that, it's pretty all easy.